Hey, welcome back, guys. I know last video I said we were going to do two topics, but I just couldn't help but break it up. It was just too perfect to separate. And you know, there are two pretty distinctly different skills going on here. And so it makes sense to separate the two videos. So sorry I lied to you guys. Hope you can forgive me. If not, it's going to be a long school year. Be very uncomfortable. But you know what makes everything better? Math makes everything better. So let's go ahead and dig into some math. So solving with standard form, right? So we learned about this thing a few videos back about standard form. And just a little refresher in case you don't remember what it looks like this, right? It's still a square equation, still has our input squared, but now it's written out like this. We don't have anything that looks like this or like this, right? Or maybe even possibly like this stuff, right? It doesn't look like this. This is our translational form. This is very close to, it's not quite vertex form, but we can consider that like vertex form. And this is our standard form, right? So it's our third form, and it has any polynomials multiplied out, right? There's no polynomial multiplication embedded into it. And I think that's the best way to explain standard form. No polynomial multiplication. That's polynomial multiplication. Binomials multiplied, right? Power 2, repeated multiplication. Binomials, right? Being multiplied. Alright, so let's go ahead and look at, now this is something we're going to use to solve some of these equations, right? So let's go ahead and look at how it's going to intertwine with some of our other math skills and how this is going to become just another layer on the set of problems that we will solve. Alright, so we have a system of equations here, right? System means more than one, so system of equations, two equations. We want to find the solution to this system of equations. So first things first, what do we want to do? Remember, eye on the prize, we're looking for the solutions to the system of equations. How do we do that? Well, one of our methods is substitution. We can substitute this y in for that y because when we're looking for a solution, these two y's would equal each other. And so it would be okay to substitute them in. So let's go ahead and perform that substitution. X minus 2 to the power of 2 plus 31 equals quantity 5x plus 1 times x minus 1. Okay? So we said that these two y's are going to have to equal each other, and so we went ahead and plugged this quantity, right, what y is equal to, into what y is equal to right there. So, cool. Now, what do we do? So, right, if you're one of the clever little birdies out there, you're going to recognize that, oh, hey, maybe we should go ahead and multiply these binomials. Because, I mean, after all, we're talking about standard form, and standard form means getting rid of any binomial multiplication. Right? And that's awesome. Good for you for using your context clues. But what about on the ACT? What about on the SAT? What are we going to do when we weren't given that context that said, hey, you should probably perform this binomial multiplication? Because you'll be able to do this a lot, right? This will be a very common option to you, but it's not always a helpful option. So why at this point do we take this option? Let's go ahead and think about this. So once we get to this point, we're now going to look at these two equations and we're going to say, okay, well, what can we do to these? Right? So we are trying to solve for x. You know, we set them equal to each other, but now we're trying to solve for x. How can we start doing that? Right? And so remember, solving for x means we get all of our x's on one side of the equation. So what can I do to get all my x's on one side of the equation? Right? And there's no clear answer to this. This is actually something that's going to take multiple steps just to get x isolated with. But looking at this, we can, you know, maybe play around with it, say, well, maybe I can divide both sides by this quantity x plus 1 term, right? Divide both sides by that, you know, essentially getting rid of it from this side. But then what's that going to do to this side? Then we're going to have this side divided by quantity 5x plus 1, right? And that's not not only going to be divided right there, but also on this term as well. It's going to divide both things by that quantity. That's going to get weird. Now we have an x in the denominator. How do we handle that? And especially with the term that doesn't have an x up top. It's going to get weird. Likewise, same if we tried out that same idea with dividing by the quantity x minus 1. We divide by that on both sides, it still gets weird. It doesn't get any closer to solving. And to be completely honest, I'm actually not aware of any math skills we could use to solve something that's going to look like that. So either of those options aren't a good option. So we want to go back to the drawing board and say, what are our options, right? What do we have left that we can do? Well, binomial multiplication, right? Get it into standard form. So let's go ahead and try that out and see what happens. So I'm going to go ahead and multiply the left side. Now realize there's actually binomial multiplication in this. So some of you guys may not have realized that. Whoops. And if you didn't, that's okay. But realize that even though we don't see two binomials explicitly being multiplied like this, we have an exponent. And what does that exponent mean? Right? It means this thing multiplied 2 times. So we want to take this, and we want to multiply this by itself 2 times. Just like we wrote right there. X minus 2 times quantity x minus 2. And then plus 31, he's just chilling there, and he just comes on down. Right? He's cool with us. Then we have these two binomials over here, and they're already written out, right? They are written out, ready to be multiplied. So now how we're going to do this binomial multiplication is with one of two methods, right? You can take your choice about how you want to go about binomial multiplication. I'm going to choose box method, mainly because it's the best, and FOIL method can suck it, but also because I'm the best at box method. Well, not I'm the best, but out of the two, I am better at box method. Right, so I'm going to choose the one that is easiest and most reliable for me. Right, if FOIL method is that for you, then go ahead. You can do that. Just understand that FOIL method is trash. Right, it's never going to compare to box method. I mean, let's just be honest. But if it's better and easier for you, you can go ahead and do that. Alright, so we're going to go ahead and do this. So how we're going to do this binomial multiplication with box method. I'm just filling this in so it's aesthetically congruent. We're going to write 5x plus 1 up here, right? And so one of my terms, the 5x term, gets this column, and then my 1 term gets this column. My x term gets this row, and my -1 gets this row. Okay? And then I'm just going to go through and multiply to find what's in the boxes. So 5x squared, x, -5x, and -1. Then I'm going to go ahead and write these all over here. So 5x squared minus 4x minus 1. And so that's actually, that's my bad, guys. I actually just skipped a step right here, right? So how did I get that minus 4x? Well, I went ahead and I recognized, hold up, these two are like terms, right? These are both like terms, and so we can therefore combine them. How do I know they're like terms? They have the same variable raised to the same power, right? They are just x terms. Okay, so that's actually the step that went on underneath there. And that, like I said, that's my bad. I'm just so used to doing these things, it just naturally happens. And you're going to get to that point too, where you're doing these and you stop showing some of these in-between steps because they just happen in your head. Okay? So we got that side done. Now let's go ahead and A, get a piece of paper under here so it's a little bit easier to write. But B, now do the binomial multiplication for the left side. Okay, so we are going to do quantity x minus 2 times quantity x minus 2. Each term gets its own space. Doing the multiplication, we have x squared, -2x, -2x, and 4. And then we're going to go ahead, and this side I will not forget, I will not combine the like terms in my head. I will write them out for you guys. We have x squared, we have -2x, we have -2x, and we have plus 4. Just like that. Okay? And now here's the part where we can combine like terms. So we're going to look for those like terms, anything with the same variable raised to the same power. So I see that, well, first I don't have any other x squared terms, so I'll go ahead and bring this down. Then I see I have 2x terms, right? So minus 2x, that's going to be minus 4x. And then I have plus 4, which is just going to come down. And then plus 31. Okay, those are combining those like terms. Now let's go ahead and combine the other like terms. Again, you may be able to do this all in your head in one fluent step, but if you can't, that's okay, right? Accuracy is our biggest concern, not the speed. Accuracy, then speed. Right, the speed is going to come naturally. So now we can go ahead and combine these other two terms. 31 plus 4 is 35. Okay, now we'll go ahead and write what's on the other side. 5x squared minus 4x minus 1. Just like that. Okay. Alright, so back to the drawing board. Now what should we do? We got to this point. What can we do with this? Well, remember, we want to get all of our terms, or we want to get x isolated. And there's actually a nice little thing in here that makes this work, a key little feature that allows us to do this. And it's this right here. Right? Our x term on the right is a minus 4, and our x term on the left is also a minus 4. So what we can do is we can add 4x to both sides, and that's going to get rid of both of those terms. And now we are getting closer to solving this problem. Okay. And the reason why this now finally kind of unlocks the problem for us, we now know that we can do this, is because now we have only one x term. Right? When we had multiple x terms, we weren't sure what to do with that. And that's actually going to be the biggest trick about solving these equations, is if you have multiple terms of x, how do you get them to be just one term? Right? And that was just, and again, that problem even persisted up here because we had this term of x, and that term of x, and that term of x, but they all multiplied together. Right? So we had to calculate that multiplication and then combine our like terms just so we could finally get to a point where we only had one term of x. Because now we can isolate this. Right? We can now solve this. We can put it to one side of the equation and say explicitly what it's equal to. So let's go ahead and do this. Let's move all of our x terms to one side of the equation. So I'll move them to the right side of my equation, just because I'm going to keep it positive. Stay positive, guys. And I'm also going to add 1 to both sides of the equation. Alright, so then getting everything else to the other side of the equation. So then 35 plus 1 is 36. Right, these two cancel. 5x squared minus x squared. That's just going to be 4x squared. And minus 1 plus 1, those are going to cancel. Alright, so we're still solving, right? We're still looking for x. So let's go ahead and keep on isolating, right? We still want to keep peeling off all these layers. Divide by 4 on both sides, because I have to multiply by 4. That's going to be 9 equals x squared. Well, what do you know? A perfect square, which makes it easy to take the square root of. Right? We want to get rid of that square by taking the square root. Now, side note, I know that in these questions, I work it out so that normally we're taking the square of a perfect square, or the square root of a perfect square, but understand it may not always be like that, and sometimes you may get a kind of nasty looking radical, and you may need to simplify it. That's okay, right? And sometimes we may get those, but understand for now, we have a perfect square that we're taking the square root of. So the square root of 9 is 3, so plus or minus 3 is going to equal x. Alright? And so these are the x solutions to our problem. Now let's go ahead, because remember, we are finding the solutions to this system of equations. We want to go back and plug in each of our x terms. So here we see that x could equal a -3 or a +3. So I'm going to go ahead and plug both of these back into my equations to find out what my y's would be for each corresponding x. Okay, so now which equation do I want to plug it into? Right, it's a good question. I'm going to go ahead and plug it into the top one. For me, I think that computation would be the simplest. If you think it would be easier to plug it into the other one, then sure, go for it. But you basically, right, you want to work smart, not hard, and you want to plug these into the simplest equation. So, taking first our -3 and plugging this back into our first equation. So our y value for -3 is going to be quantity -3 minus 2 squared plus 31. Now doing my PEMDAS, right, because I'm evaluating, I am simplifying to see what y is equal to. -3 minus 2 is -5 plus 31. I know that -5 squared is 25 plus 3. 25 plus 3 is going to be 28. So my first solution, right, is -3, 28. Awesome. Right, that's solution number 1. Now realize there's going to be multiple solutions for this. Okay, we're solving an equation with a square in it, and that means there definitely has to be at least 2 solutions, fundamental theorem of algebra. Also, we can think about this as both of these being squares, so we know that both of these are going to turn, and when they do turn, when they have that turning point, they're going to be able to loop back around and hit each other one more time, be able to intersect each other one more time. Okay, so that's solution number 1. Let's go ahead and find solution number 2. How we're going to find that is now by plugging in our 3 into one of our equations. Again, I'll go ahead and stick with that first equation. So we see that y is equal to, and this time we're plugging in 3 for x, minus 2 squared plus 31. Right, so y is equal to, again, doing PEMDAS downwards because we're simplifying. We're not changing both sides of the equation, just simplifying one of them. 3 minus 2 is 1. 1 squared plus 31. And then 1 squared, I know that's just going to be 1 plus 31, which equals 32. So our solution is 3, right? We plugged in 3 for x, and y is 32. Just like that. Okay? Hefty problem. Definitely a beast. Right? But you see how standard form was integrated into this? Right there. Right? When we turned this into standard form, it allowed us to solve these. Sometimes that's going to happen. Sometimes that'll be the magic trick. Right? Math is a puzzle. These problems are challenges. And sometimes you got to play with the puzzle before you can get to the correct answer to it, before you can solve it. Next example. Find the square equation which contains points 1, 4, -1, 0, and 0, 5. Okay, so we're looking for a square equation that's going to contain these 3 points. And so again, right, context clues, we know that we're going to be using standard form, but how else could we come up with this idea? Well, think about it like this. We have points, right, and we know that we can plug that into different versions of our square equation. Right, we know it's going to be a square equation, and we know that these are our x and y coordinate points. We can plug those in to see what kind of equations we get. Now, the short of it, so I guess, I'll go ahead and tell you the trick to this. The cool thing about doing this, so let's go ahead, we're just going to run with standard form. We're going to make a realization about this. So plugging these into our standard form, we have 4 equals a times x squared, so 1 squared, plus b times 1 plus c. And then we're going to have 0 equals a times negative 1 squared plus b times negative 1 plus c. And then we're also going to have 5 equals 0, well, a times 0 squared plus b times 0 plus c. Okay? What ideas do we have? I don't know about you guys, but I recognize a system of 3 equations with how many variables? 1, 2, 3. Oh, whoa, we just went that far back. Yes, we did, right? We're going back to quarter 1 material. We're going back to matrices. We're going back to systems of 3 equations and 3 variables, which we know we can solve with matrices, right? I mean, you know, tell me if I'm wrong. How many variables? 1, 2, 3, right? And how many equations? 1, 2, 3. Can we solve that or can we not solve that? We can, right? So, realize that's kind of the beautiful thing about standard form. It writes our quadratic equation in a way which gives us 3 clean variables. Now, side note, and I encourage you to do this. Actually, I'm going to go ahead and pose this challenge problem, and we're actually going to put quite a hefty line, quite a hefty price on it. So, how many points, if you were to do this, but without standard form, if you were to do this using vertex form, right? If you were to do this kind of method where you write out all your variables and then solve it with vertex form, how many points would you need? Go ahead and think about that. And once you find the answer to this, you're going to realize that doing this with standard form is a more friendly form, right? It's a little bit easier. It's a little bit less work, not in the cheap kind of way, not like you're slacking off kind of less work, but like in a smart way, like taking a smart cut. Okay? So either way, right, now we got here, right? We have 3 equations and 3 variables. So we can go ahead, we can write this as a matrix, right? And so, writing this as my matrix, these are my constants, right? They go over here, 4, 0, and 5. And then I'm going to write what is going to go in here, right? I'm basically just going to take this data, take this information, and put it into a matrix. Alright, so my first equation, I have 1a. My second equation, I have 1b. My third equation, I have 1c. My third equation, I have, so what's negative 1 squared? That's just 1. I have 1a. I have b times negative 1, so that's negative 1b. And then c, I have 1. Right, just have one of those. Okay, and the last one. So a times 0, that's going to be 0, right? I have 0 a's. 0 squared is 0, so I have 0 a's. And then b times 0, again, 0 b's. And then c, I have just one of them. Okay? And so, right, and so for some of you clever cats out there, you may realize, oh, wait a second, I see that c must be equal to 5. Right? And you are absolutely right. C must be equal to 5. But we still need to go ahead and solve for a. Now notice, you could actually go about this and maybe solve it via substitution or elimination. You could totally do that. And I encourage you to go try that out. Try that out and see if you get the same method or get the same answers by doing it with our calculator. Okay? But for the time being, right, I'm going to exercise my matrix. I'm going to use my Gaussian elimination. And so I'm going to go ahead and calculate this using a matrix. So going into my calculator, creating that 2x3 matrix. Oh, and actually we're going to have a 3x4 matrix here, right? We want 3 rows, 1, 2, 3, and 4 columns, 1, 2, 3, 4. Now go ahead and enter in my data in. So 1, 1, 1, and 4. And side note, the way these calculators are going to go, they're going to go from left to right, so you can just enter the data in as you go and hit enter after each number. And it should catalog all that in there. Okay? Just entering my data in, and we can go ahead and just review this once we're done just to make sure that we entered it in all correctly. Okay, so this is the far right hand side, right? See those brackets? That means it's over as far right as it can go. So 4, 0, and 5. Nice. Then I see the 1, 1, 1 next to it. I see the 1, negative 1, 0 next to it, and the 1, 1, 0 next to it. Also realize this wouldn't be a hard matrix to solve by hand. This would actually be really friendly and easy to solve by hand. So if you want to go ahead and try that as well, I encourage you to do so. So, going ahead, and now we're going to have our calculator find out what the reduced row echelon form of this is going to be. Going back into matrix and going to our matrix math, and go into the RREF, right? There's not enough room to write reduced row echelon form. Oh, whoops, that's my bad. I want to quit out of that, right? My matrix is saved. If I go back, I can check on it. It's right there, right? It's all saved. Now I want to go back to the home screen. Okay, because that home screen is going to help us calculate it. So I'm going to go into the matrix, under math, select our reduce row echelon form, right? That's what we want to do to our matrix. So now we're going to go ahead and put in our matrix. And we're going to select our first matrix. That's one we want, reduce row echelon form. And we simplify it, and this is what we get out. Right, our matrix reduced into simplified form, and this is now going to tell us what each of our variables is equal to. Cool, and so from here, what this is going to mean, so therefore, A is going to equal negative 3, B is going to equal 2, and C is going to equal 5. Right, just like we predicted, which is good. Okay, so now let's go ahead and write the equation for our square equation. Let's go ahead and write it. So we have y equals negative 3 x squared plus 2x plus 5. And that is our equation.